Welcome to Math Zone African Motives. Today, we're diving into a fundamental concept in calculus, integration. You can find more tutorials on our channel, so make sure to subscribe. Our main goal in this video is to solve two specific integral problems using simplification and standard integration formulas. First, we will focus on problem number 8. We will tackle the integral of cos squared x divided by 1 minus sine x. By the end of this scene, you will be able to solve this integral by first simplifying it using trigonometric identities. The key here is that this integral isn't one we can solve directly from our standard list. We need to simplify the expression, known as the integrand, before we can integrate it. So, we must simplify or manipulate the given integral. This is a common strategy in integration problems. Let's begin. We have the integral of cos squared x over 1 minus sine x. The first step in simplifying this fraction is to look for any trigonometric identities that can help us. Notice the cos squared x in the numerator. This term, cos squared x, should remind you of a very important identity. That's the Pythagorean identity. Sin squared x plus cos squared x equals 1. This formula relates sine and cosine. We can rearrange it to get an expression for cos squared x. Let's subtract sine squared x from both sides. We get that cos squared x is equal to 1 minus sine squared x. This substitution is the breakthrough we need. Now, let's substitute this back into our integral. We are replacing cos squared x with the expression 1 minus sine squared x. Our integral now becomes the integral of 1 minus sine squared x, all divided by 1 minus sine x. We have successfully replaced a cos term with a sine term, which is helpful. Look at the numerator now, 1 minus sine squared x. This expression has a specific algebraic form. It's a difference of two squares. The difference of two squares formula states that a squared minus b squared equals a minus b times a plus b. In our case, a is 1 and b is sin x. Applying the formula, the numerator becomes the quantity 1 minus sine x times the quantity 1 plus sine x. So 1 minus sine squared x factors into 1 minus sine x and 1 plus sine x. This allows us to factorize. Now we have a factored numerator. Let's put that back into our integral. The integral is now the integral of 1 minus sine x times 1 plus sine x all over 1 minus sine x. Notice that the 1 minus sine x term appears in both the numerator and the denominator. This is excellent. It means we can cancel that common factor. This is why we factored it in the first place. Canceling the common term simplifies our integrand dramatically. We are left with something much easier to handle. The integral has simplified to the integral of 1 plus sine x. This is the simplest form we can get, and it's ready for integration. Now we use two standard integration formulas. Remember that the integral of a sum is the sum of the integrals. We can split this into two parts. The integral of 1d plus the integral of sin x dx. First, the integral of 1. What function, when differentiated, gives you 1? It's just x. The formula for the integral of a constant k is kx. So the integral of 1 dx is x. We will add the integration constant c at the very end. Next, we integrate sin x. We know that the derivative of cosine x is negative sine x. Therefore, the integral of sine x must be negative cosine x. So, the integral of sine x dx is negative cosine x. This comes directly from our list of standard integrals. Now, let's combine our two results. The integral of 1 dx is x, and the integral of sine x dx is negative cosine x. Putting it together, the solution is x minus cosine x. Finally, we add our constant of integration, plus c. This is our final answer for question 8. The integral of cos squared x over 1 minus sine x is x minus cos x plus c. Comparing our step-by-step solution with the provided memo, we can confirm that it is verified. Welcome back. In this scene, we will tackle our second integral problem. By the end of this tutorial, you will be able to integrate a difference of trigonometric functions by applying standard integration formulas. Our task is to find the integral of 1 over sine x minus 1 over cosine x. Again, this doesn't immediately look like any standard integral, but before we try complex manipulations, let's simplify the terms in the integrand using basic trigonometric definitions. Recall the definitions of the reciprocal trigonometric functions, cosecant and secant. Cosecant of x is defined as the reciprocal of sine of x. That is, CSE x equals 1 over sin x. Similarly, secant of x is the reciprocal of cosine of x. So sec x equals 1 over cos x. We can substitute these definitions directly into our integral. This will make the expression much cleaner. The integral now becomes the integral of cosecant x minus secant x. This is the first step of simplification. Now we have an integral involving the difference of two functions. We can use the property that the integral of a difference is the difference of the integrals. This means we can rewrite our expression as the integral of cosecant x minus the integral of secant x. This breaks the problem down into two parts that we can solve separately. Let's find the integral of each part. First, the integral of cosecant x. This is a standard integral. The formula for the integral of cosecant x dx is 1 over a times the natural log of the absolute value of the quantity cosecant x minus cotangent x plus c. In our case, the coefficient a is just 1. So the integral of cosecant x is simply the natural log of the absolute value of cosecant x minus cotangent x. We will add the constant of integration at the end. So the first part of our answer is ln of the absolute value of cosecant x minus cotangent x. Next, we need the integral of secant x. This is another standard integral. The formula is 1 over a times the natural log of the absolute value of the quantity secant x plus tangent x plus c. Again, with a equals 1, the integral of secant x is the natural log of the absolute value of secant x plus tangent x. This gives us the second part of our solution. ln of the absolute value of secant x plus tangent x. Now, let's combine our two results, remembering that we are subtracting the second part from the first. Our solution is the natural log of cosecant x minus cotangent x, minus the natural log of secant x plus tangent x. This expression is correct, but we can simplify it further using a logarithm property. The property for the difference of logarithms is that the natural log of a minus the natural log of b is equal to the natural log of a divided by b. Applying this, we get the natural log of the absolute value of cosecant x minus cotangent x divided by secant x plus tangent x. This is a more compact form. Finally, we must remember to add the constant of integration, plus c, to our final answer. So, the integral of 1 over sine x minus 1 over cosine x is the natural log of the absolute value of cosecant x minus cotangent x over secant x plus tangent x plus c. We can also see that the solution provided in the memo, ln cos x ln sec x plus tanx plus c, is the same answer before we applied the log property. Therefore, our solution is verified.